Right, our rotation rules, they work when we rotate about the origin. If a point is not specified, it's assumed that you're rotating around the origin and always in a counterclockwise direction unless it states otherwise. That's how our rules work. So if we rotate 90 degrees around the origin, the y coordinate comes to the front and switches signs, the x goes to the back and remains unchanged. When it's 180, they stay put and they simply switch signs. And when it's 270, y comes to the front, x goes to the back and switches signs. We're familiar with these rules and we've used them, but what about a different center of rotation? What if we are not rotating around the origin? What then? Well, I'd like to show you a couple of different ways to go about this. So this is the introduction to the notes. You could pause it and copy those down for a second. And then we're going to go ahead and we're going to look at this particular problem. And what I want to do is I want to rotate it. So here are the instructions. Let's rotate this triangle 270 degrees about R. So we're going to rotate this thing around point R. I'd like to show you more or less what it's going to look like and how we're going to get there. So I've traced it with transparency paper. And normally when we rotate 270, we would rotate around this point, the origin. Let me just show you what that would look like, and I want you to see how very different they are. So if I rotate around the origin counterclockwise, this would be 90. This would be what it looked like at 180, and this is what it would look like at 270 degrees. But that's not what we're going to do this time. This time I want to rotate around point R. So let me just make the same thing I just did, a little grid mark, just so I can see when I've locked back in on those 90-degree rotations. So if we rotate around R, we'll still go counterclockwise since it doesn't say. This would be a 90-degree rotation. This is what 180 would look like, and this is what 270 is going to look like. And it's possible, again, that some of you are really good at visualizing that and can just get the triangle there. But if not, I want to give you a couple of different techniques for making this rotation happen. So that's what we're trying to do. Let me show you how to get there. So one technique, so let's just call this method 1, okay? Method 1. The first thing we should do is make sure we have good ordered pairs for these points. So S is at 1, -1. Let me think about how I want to do this. Let me just write these across the top right now. R is at 5, -1, and I is at +1, -4. Okay, one way to do it is to take our center of rotation and drag it to the origin so we can use these rotation rules, and then we'll just move it back where it was. So it's a 3-step process. So step 1, the first step is to translate to the origin, okay? So I'm gonna do that. So if we do that, let's start with R, because R is the point. You're translating the center. The center of rotation is the one that's going to move to the origin. So how far do I have to move R to get it there? I would have to move it 5 to the left and up 1. So that means I would be subtracting 5 from the x coordinates and adding 1 to the y coordinate in order to move R there. This translation rule would get R there. Let's do R first. So after step 1, R would be sitting at 5 minus 5 will put me at 0, and -1 plus 1 will put me at 0. But this is rigid, and if I drag R, the whole thing's going to move. In fact, it's going to look like this when we're finished with these ordered pairs. We're going to push R 5 to the left and up 1, and the whole triangle is going to move, and we're going to find these new points right here. So in order to find S, if we subtract 5 from 1, S will sit at -4. and we're going to add 1 to the y coordinate of s, -1 + 1, 0. And that surely is where s is sitting right this second. And then let's do the same thing with I. So subtract 5 from 1, and that'll put us at -4. Add 1 to -4, and that would put us at -3. And if we go, this is the origin, -4, -3, there's I. So why did we do that? We did that so that we could now use our rotation rule and spin it. So step 2 is to just go ahead and use the rules. So we want to rotate 270, and that rule is y comes to the front, x goes to the back and changes signs. So I'm going to rewrite these points for just a minute so we can go this way. And we'll use this rule. So when we do that, s is going to move. The y is 0. It will come to the front and remain 0. The -4 goes to the back, and this is going to change the sign. So it'll become +4. If you flip places with the 0 and the 0 and swap signs, you'd never know you've done anything, and that's because r is our center of rotation. And then for I, y will come to the front and stay the same. Y is -3, so it stays -3, but x goes to the back and changes signs. It's -4, so it becomes +4. So let's see that happens. So remember we slid our triangle here. Now if I rotate it 270, this would be 90, 180, and 270. This is where it's sitting at step 2 in this process. And notice that s is up at 0, 4, sure enough. R is still at the origin, and I is left 3 and up 4. Now the only thing left to do, we've rotated, now it's to translate it back. We want to undo what we did up here in step 1. So step 3 is to move the center back to its original location. And we're just going to undo what we did up here in step 1. So in step 1, we subtracted 5, we moved it 5 to the left. So now we'll need to add 5. And in step 2, we moved it up 1. So now we'll just need to move it down 1. So I'll come back to my picture in just a moment. Remember, this is where it was sitting. So I just want to rewrite these here again so we have something to work with. And I'll show you, we don't have to write quite so much if this becomes the technique that you want to use. But let's just go ahead now, and this will put us in our final position, so I'll go ahead and give it the primes now. So I'll add 5 to the 0 and get 5, and subtract 1 from 4, and I'll get 3. R prime should end up right back where it started in its original position. It's the one that kind of was the impetus for all the moves we made. So I'll add 5 to the 0 and get 5, and subtract 1 from 0, and I get -1. And then I prime, adding 5 to -3, that'll put us at 2, and subtracting 1 from 4 will put us at 3. Okay, so remember our triangle was sitting here, and if we slide it back to R, if we go 5 to the right and down 1, this would be the final location, and you can see that S is over 5 and up 3, that's S prime at 5, 3, and I is over 2 and up 3, and I prime is at 2, 3, and then R prime is just right back where it started. So this would be my image. So that's quite a lengthy process in order to make that happen. So I'd like to show you a different method, and we'll see what you think about it, okay? It's much quicker, but it might just be a little trickier to wrap your head around. The other way to do it is to just think about your movement from the center. using the 270-degree rules. So here we go. I need to just show you. All right, so how do we move in our pre-image, which remember is our original, and then how will we move in order to create the image? All right, so this is all just geared with the center. So remember that we're rotating about R, okay? So R is my important point. So right now, how do I get from R to S? If I wanted to do a translation rule for that, sort of, to get from R to S in the original image, I have to only move to the left 4 and I'll be there. So I go left 4 and I don't move at all vertically. I just stay put, okay? So that's 0. We're rotating 270 degrees, and the 270-degree rotation rule that we just used a moment ago is Y comes to the front and stays the same, and X goes to the back and changes. So I'm going to use that in terms of my movement. So how will I get from R prime to S prime in my image? The distance between these points is the same. So this method works because this transformation is rigid and none of our side links are changing. So what happens? Y comes to the front and doesn't change. Well, notice Y was a 0. So this time I'm not going to move my X location. There will be no change there. And going left 4 was a negative movement. So when I move it to the Y position, it's going to become a positive movement and I'll go up 4. Okay, so what does that mean? It means that on my diagram, if I want to get from R prime, since this is the center of rotation, it is both R and R prime, I am not going to move left or right. I'm only going to go up 1, 2, 3, 4, and that will put me at S prime. All right, let's go back and let's do it again. So the other point on the triangle was I. So let's run through this again. In order to get from R to I on the original image, what has to happen? Let me just do this so you can see it better. So to get from R to I on this original image, we have to go left 4 and down 3. So right now we're going left 4 and down 3 in order to move there. To get from R prime to I prime, I'm using this ordered pair rule. So Y is going to come to the front and remain the same. So we were going down 3, that's a negative 3, and that means I'll go left 3 because that's negative in the X direction. And then X will go to the back and change signs. So X is moving in the negative direction. So when I put it in the Y position, it needs to move in the positive direction, and that will be up 4. So if I start at R prime and go left 3 and up 4, that will put me at I prime. So starting at R prime, going left, 1, 2, 3, and up 1, 2, 3, 4. This will be the location of I prime. And there it is. And if I just do my transparency paper one final time, I can remind you that sure enough, if I hold this at R and I rotate 90, 180, 270, that's where I land. Okay? All right. So we'll practice.